when we talk about the inductive effect, we're also thinking back to electronegativity, but it's more of an indirect electronegativity. So with electrophilic aromatic substitution, we talked about the inductive effect of different original groups or substituents on a benzene ring and how that affected the reactivity. We're essentially doing the same thing here. And as an example, let's consider the difference between in the acidity of trifluoroacetic acid versus acetic acid, which just has hydrogens. Now, again, if we're thinking about the acid strength, what we're really comparing is not the acid strength itself, but the strength of the conjugate bases or their stabilities. So it won't hurt to draw those. Now we already know that both of these species have resonance. So when we put the negative on just one of those oxygens, it's a little bit misleading. And we might actually use the resonance hybrid as a better picture of that negative, which is really delocalized or spread out between the two oxygens. So let's actually put it on the two oxygens as a partial minus. And since there's no difference in the two oxygens, really they'd each be -1/2. Now consider the effect of the highly electronegative element on the bonds. So we have 3 fluorines. Fluorines is the most electronegative element in the universe. And so these are very polar bonds between this carbon and the fluorines. And that we'd say is an inductive effect. It's basically bond polarity. But there's an indirect effect as well, because that carbon in turn, now that it's short of electrons, is going to pull more from its neighbor. And we're indirectly pulling some of the negative away from the oxygens with the fluorines. So the fluorines are going to actually pick up a little bit of that partial minus charge and to help further delocalize it or spread it out or take it away, relieve from the oxygens or relieve those oxygens from their burden. So that makes this one, the trifluoroacetate, more stable and therefore a weaker base. And that makes trifluoroacetic acid the stronger acid. And in fact, if we look at the pKa values, the pKa of trifluoroacetic acid is actually about 0, making it technically a strong acid by our chemical principles definitions. And the pKa of acetic acid is about 4.7. So it's almost 100,000 times difference in acidity. Now that inductive effect drops off quickly with distance. So if we look at another example, in this case we have 2 butanols, or 1 butanols, and each one has a chlorine on it, so same element, same electronegativity, but the chlorine on this one, 4-chloro-1-butanol, is considerably further away. And that inductive effect, I'm trying to draw these arrows smaller and smaller as we go, falls off quickly with distance. So it's going to be a lot stronger the closer the electronegative element is to the source of the charge, in this case the oxygen that'll become negative. And so in this case, when we're making a comparison based on the inductive effect, We got two alcohols, so we have the same functional group, right? We were making a comparison between equivalent functional groups. The only difference is the proximity of the chlorine. The closer the chlorine is, or we'll say the electronegative element is, the stronger the effect. So this would be the stronger acid, because that chlorine is going to stabilize the conjugate base more because it's closer.